Ready.
Ready's ready.
All right. That's right. All right, this is group 7, lesson 14, group meeting. All right, so part 2, the ANOVA. According to William Butler Yeats, she is the Gaelic muse, for she gives inspiration to those she persecutes. The Gaelic poets die young, for she is restless and will not let them remain long on the earth. One studies designed to investigate this issue examine the age of death for writers from different cultures and genders. 3 categories of writers examined were novelists, poets, and nonfiction writers. The ages at death for female writers in these categories from North America are given in the womanpoet.sav data. You would like to determine if the mean age of death is different from any of the categories of writers. And we're using 0.05 as our level of significance. So we need to go and pull up our women. Yeah.
Okay, so I have a question. So you know how, like, in the instructions, it tells you to, like, here, let me get it exactly. So you know how, like, when it's telling you to do the plots, and there's also one more, and it tells you go in and change. Where is that? Oh, like, it tells you to click on options and hit descriptives and means plot and things like that. Do we have to do that every time, or does it save it? Does that make sense?
For every new one, you have to do it every time.
Okay, that makes sense. Okay. Because we have to retell it to do that kind of stuff.
Yeah.
Now, and then do we have to well, and then, like, and so my other question is, because to me this looks like it's already sorted, so we don't have to automatic recode, right?
No, you don't, because it's already in numerical numbers.
That's what I thought. Okay. Like, why does that have to be all confusing?
Same thing.
Oh, and Stacy, this one's for you. So now we're on to an F statistic.
That's right. That's right.
This is like what, our third, fourth?
Yeah, you first had Z, and then you had, it's our third, you had T, and then you have, D, and now you have F.
But wait, where was D?
What was that?
Where was the D?
Well, D kind of used, no, I said D, but D used T, so it's our third.
I'll be right back. Hold on.
Okay.
I was going to say, wait a minute, where did you find the D? I haven't seen that one.
Right. Right. Okay, so they're going to want to know the descriptives and all the other stuff. I guess we'll wait for Carrie. But
okay, so
are you guys there?
All right, yeah.
Okay, sorry.
So now we're going to go, you're fine. Now we're going to go up to analyze, and let's do the descriptive statistics. I'm just going to pull up all that stuff. So I put age in the dependent list and type into the factor list. And then I go to plots. Make sure I click normal plots with tests. And he said you can even click that histogram on the right. And it will. Yeah. And then hit OK. What was that?
Because you have to use the QQ plots because you don't get a normally distributed sample.
Oh, right. Where's that on this one? Oh, it's on. Yeah. Oh, it is creating the QQ. Yeah, it would automatically create that QQ plot on plots. Okay, so then hit OK. And it should. Oh, there we go. I was going to say, come on, pull it up. So there's our descriptives.
Let me see if mine match yours, please.
QQ plots. Do you want me to pull mine up or?
Oh well. Okay, I'll just. So I'm only as far as doing the means.
Okay.
So do you have 67, 32 for your means? Do you have 67, 32, 24?
For which one?
Descriptives. Not mean. Sorry. What does N stand for again? Crap.
Number, sample size.
Oh.
Yeah.
Okay.
Yeah. No, you're fine. Yeah. So I have 67, 32, 24.
Okay, so okay, we got the same. And so we have that, and then we have to analyze descriptive statistics and explore.
Yeah. So we'll go back up to one. I guess what is the designs? So A, what is the research question?
Oh.
Is the mean age of death different for 3 categories of writers?
Yeah. And then they want you to state the null and alternative hypothesis, which the null for an ANOVA
Is always,
will always,
they equal
yeah,
each
go
other.
ahead.
Always going to be,
Yeah.
all the means are equal.
Yep. And then the alternative is there's a difference in age and death in different female authors. Or excuse me, there is a difference in the means.
There's
Of one or
only
more.
Okay.
one of them different.
I bet they're gonna. Well, I
Yeah.
have so far we have yet to like actually be. Never mind. I won't jinx us.
That's right. All right. Describe the data collection. I was trying to figure
I
that
have
out.
no idea.
Yeah. Well, and that's what they had in the answers. They don't know how they collected it. So I'm like, thanks. That's good. Now in 3A, they want us to describe the data. So for number 1, which is the novelists.
It's a lot of numbers. That's how I describe it.
That's right. The mean is 71.45.
Oh, wait a minute.
Right?
Go ahead.
What mean are you looking at?
So if you look under on SPSS,
Under descriptives, right?
so mean the type where it says, yeah, it says type 1. That's our first one. That's the novelists.
Right.
That's what they, and so the mean is 71.45.
Right.
And that's it. And then the standard deviation is 13.052.
Right.
And then go ahead.
I'm just like, so do we only so
when
we're on number 3, right? So we're just describing the data.
Yeah.
Okay.
Yeah.
And I was like, I thought we dealt with it as a whole. Sorry. Ha.
Yeah. No, for when they want you to describe the summary statistics, in this one and in the paired and independent studies, they want the individual groups. So you do it for all 3. So
I got you. Sorry.
No problem. The sample size for number 1, the novelist, is 67. And then if you go to 2, which is the poets, the mean is 63.19. Deviation is 17.297. And sample size is 32. And then 3 is the nonfiction. Their mean is 76.88. Standard deviation is 14.097. And sample size is 24.
Sounds like
So,
you don't want to be a poet because they die sooner.
exactly.
And they probably die poor.
It's because they're too emotionally charged, too much stress, too much, I don't know.
There you
All
go.
right. So question number 4A says, what type of hypothesis test is appropriate?
Well, it's the ANOVA.
Yeah, because there's more than 2 groups, so that's pretty easy. What are the requirements for this test?
Oh, well. The data are normally distributed and the variances are equal.
Yeah.
Well, what's funny is they say it's a requirement, but you can't figure that out until you do the work.
Well, right. Well, they want you to pull up those QQ plots because then you see, and then you go look at variances and make sure that the smallest variance isn't 4 times smaller than the larger one.
you know how in the SPSS it makes you, it says look at the variances, like what you were just saying, Stacy.
Yeah.
And then it tells you like, well, you can use the SPSS, and then it tells you to go to that descriptive. So, but where are we looking? Like, if we, before that step, does this make sense to you? Like, where are the variances on the plots? I don't get that part.
Well, the variance is just they're not really on the plot. They're just in the descriptives. The variance is the standard deviation squared.
Right. But because
Right.
you know how like it created when you do the stem and leaf plots, which I didn't even know was going to rename them. So where's the standard deviation on that? I don't see anything labeled. Yeah. I only see it under just the actual descriptive. Well, I didn't see it until they told me to go to analyze descriptive statistics and explore. I was just wondering if you guys saw it, and I'm just like missing it.
No, that's where
No, not there.
That's where I found it. It's just, yeah.
I got you.
C says, are the requirements met this test? Explain. We go down and look at those QQ plots. And looks like it's fairly normal. Normal enough to proceed. And then the largest variable, if we go back up and look at our chart, we had 198 point something, 299, and then 170. So 170.342 is our smallest, and it's definitely the 4 times of the 299. So the answer would be yes. It meets that. Okay, so now we need to go up and compute our test statistics. So you go to analyze, compare means. Go
and then
down
do
to
that one note.
Yeah.
ANOVA.
One way ANOVA. Put in the age in the dependent list. Type in the factor. Go to options on the right. Click on descriptive and means plot. And then hit continue and OK. And then it gives us that information.
And it'll give the ANOVA.
What was that?
In the box that has ANOVA over the top of it.
Yeah. Yeah. So so what's the test statistic, Chris?
6.563.
Yeah, 6.563. The degrees of freedom. This is somewhere I'm not confused in the sense of I know what answer they want, but I don't know why they want it the way they do. But
well, because one is in between and the other one is within.
Okay.
So you have to get both degrees of freedom. You have to get the one that's within the count thing and the other one that's. Oh,
yeah.
No,
so it's kind of like the 95% where you need the lower.
That's right.
Well,
that's right.
You need to know that you need an ANOVA. You need to have both degrees of freedom.
I wonder how on the on quizzes and tests it's going to ask for, because like.
Right.
Like, do we put a comma between them, or are there going to be 2 boxes?
Right.
We'll find out in our.
We'll find out, right? Yeah. So we have.
You'll have to probably put a comma.
So, because the instructions say don't look at the total, so you just need the between, which is 2, and within, which is 120, right?
Correct. Yeah. And then the next question is compute the p-value and compare it to the alpha level. And so that's that signature sig. I mean, I don't know what that means. Which is 0.002. Compare that to 0.05. And
the sig is the
and it's less.
It is less, so we reject that null hypothesis. So on H it says
which means
present
that we have evidence that one or more of the means of the ages of death is different.
So did you guys understand the way I'm understanding that when we're looking at that sig, it says the p-value for the ANOVA tested in the area is in the right tail. We will never divide the area. So we take that as a face value, right?
Yeah, it will always be that.
Okay.
Yeah.
All right. I just wanted to make sure I was reading it the same way you guys were reading it.
Yeah. And then number 5 says, take action. With further study, we find poets die earlier than the novelists in fiction. What significance can you conclude? Don't be a poet. Poets are too emotional or suicidal. I don't know. Yeah.
There's too many variables. We wouldn't know.
Yeah. Okay, so let me ask you guys this. So on our homework in the lecture, it showed all of those it showed what would be similar to the student T distribution applet. Remember how it showed those plots in it? And I was thinking, well, where do we go to find those? Anyway, I didn't know if there was a special place or not, but I think what they're doing is just taking the half of that. I don't know if there is a place. Did I miss something?
I think, no, you didn't miss something, but I think what they want on the plot is that it has to be right skewed.
Yeah. So they're just cutting off that applet on the right or something.
Yeah,
okay.
On the right.
Okay.
I don't think the plot will, I don't think the gravity.
Yeah. Well, I didn't see it. Yeah. I didn't see anything anywhere, but I just wondered if I had missed something. But
no,
all right, should we start our? Okay. Should we start our quiz?
Sure.
No, wait a minute. I gotta get to it. Wait.
Okay. I'll wait for you.
I guess no Eduardo tonight.
Yeah, it's not looking like it. Okay, I'm gonna go open up. Oh, and they tell us if we need it. Here's a link to the normal probability applet, but
I think they just standardly offer it now.
that's just what they do all the time. I'm gonna go open up those 2 files just so they're open. It's the soccer shoes and the DASL hot dog nutrition. I'm excited.
I know it like moves down as you open them, but it still can. I always close them and like want to open them individually. You know what I mean?
I know, because I don't want to be confused. Let's see. All right. Let's see the hot dog one.
Oh, great. Hot dogs, huh?
I know. What was it called again? Nutrition. Okay, I lost it.
There isn't any. I don't know what we're studying.
Oh,
working on.
DASL. Okay. Hot dog. All right. So, come on, open up. There we go. All right. Let's see. I'm going to close those other ones. Do you guys hear that?
What was that?
Well, do you guys hear that? Would I close something and
No, but your
okay.
Microphone's cutting out. Okay.
All right. Sorry, maybe because I'm. All right. Ready for question 3? In ANOVA hypothesis test, we reject the null hypothesis when there's sufficient evidence to indicate at least one mean is different from the others.
That's
true, right?
I agree. True. Okay. Question 4. What requirements need to be checked when performing ANOVA hypothesis test? Mark all that apply.
Data in each group are normally distributed and variances are equal in each group.
Yeah.
Okay. To check if each group is normally distributed, do the following. Construct a scatter plot of the data in each group, construct a histogram, or construct a QQ plot. Isn't it a QQ plot?
That's, yeah.
Which makes me think of
Okay.
Q-tips, by the way.
Right.
Okay,
Right.
What you
so
article?
I'll keep on reading. We assume the variance in each group is the same if the following happens. The sample variance in each group is smaller than the sample mean. The largest variance is less than 4 times the smallest mean variance. Sorry. The largest sample mean is less than 2 times the smallest sample mean. Each group has the same sample size.
I would say Laura. Go ahead.
Now I'm all confused. So
Largest variance is less than 4 times the smallest variance.
No, because
I thought it was the opposite.
greater.
Oh, okay. I'm reading it right now. It says the rule we use is if the largest variance is less than or equal to 4 times the smallest.
Yeah. So that's number 2.
So it is. So it isn't B.
Number what?
Yeah.
Sorry, I've had this like really loud train going by. Okay, stop.
I can barely hear it.
It's well, we have houses between us and the track, but like there's not a whole lot of sound barrier. And seriously, at night they will like lay on their horn the whole length of town. I was like, really? Is that necessary? Okay, sorry.
Right.
A ANOVA hypothesis test is equivalent to conducting independent 2 sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs if there are 4 samples? Yikes. We have to do math now?
Would it be 4? Well, no.
Well, because your options are 1, 1, 2, 2, 1, 2, 3, 2, 4, 1, 4, 1, 3.
Let's see. 1, 2,
Um,
1, 3, 1, 4.
And
It would be 2,
we don't
3.
have to go backwards. So 1, 2, 3, 4, 5, 6.
Let's see. It would be 2, 3, 2, 4, and then 3. It would be 5 or 6. Let's see. There'd be 1, 2, right?
Yes.
1, 3, and a 1, 4.
Yes.
And then there would be 2, 3.
2, 1. Well, no, we wouldn't do it 2, 1. So we wouldn't.
Because we have a 1, 2, right?
Yeah, we wouldn't have to do a double.
And
I'm thinking.
And a 2, 4.
Okay. 2, 3, and 2, 4.
What about a 3, 4?
And then we would need a 3, 4. So 1, 2, 3, 4,
Okay.
5, 6.
1, 2. Yeah, I think you're right.
I had my numbers, the overall number right, but
Man, I don't like that question. Okay. The data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for the total of 6 groups. Each row represents a kick from the 10 millimeters away or 10 meters away from the target that was hung at 115 centimeters from the ground. The column accuracy is the distance from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Use this scenario for the next 5 questions.
yikes.
What is the smallest variance for the 6 groups? Okay, so if we have to go in and get let's go change our.
We don't have to transform, right? Because there's only 2
We need to recode
footwear because it doesn't have a binder.
No yeah, there's no number. So.
Because they're all A, B.
Yeah. So
okay.
I'm going to do
automatic recode. And we're taking footwear over to the variable, right?
Yeah.
I'm going with shoes as my new name. Shane.
Shame.
Just saying. And then
go to analyze descriptive statistics. I'm going to put footwear code in there, but we'll go to plots on the side and hit normality plots with test and histogram if you want.
Wait a minute. I'm confused. Okay, so we do the auto.
The auto recode.
Okay, and then we go analyze, compare means, and they go one-way ANOVA. Compare means, one-way ANOVA, and then move the variable containing your data to the dependent list. So that would be our rename, right?
The dependent list will be the kicking accuracy. We were trying.
And then our factor is the shoes.
The footwear code or whatever you renamed your file.
Okay. And then
Sorry, my dog is barking. Sorry, I'm gonna go let my dog out.
Okay.
Go out.
Click on options, descriptives, mean plot.
Okay.
Okay, continue. Okay. Okay, so
Did you already do your descriptives?
yes,
okay.
I'm waiting for you.
I'm here. Let's see. So let me find my. I'm going up. I'm finding it. Oh, it's still all processing. Why are you still processing? Okay, come on. All right. So it wants to know which variance. What was the question again? I forgot. Which variance is the smallest? What's the smallest variance for these groups? So if we go look, A was 27.358. Is that what you guys got?
I'm sorry, what are we comparing?
It wants to know which variance is the smallest.
I'm only at descriptives. Can we find it in descriptives? Didn't he say like the very okay, I have to be like Chris. They have us do all this roundabout work, and then there's a little sentence going, "Oh, you could have gotten that answer from the very beginning."
Right.
Okay, so that little last sentence and says you can see the variances. Where did I see that?
Yeah, I'd like to know because I remember in the lesson it seemed easier to get the variances, but.
Okay, so if you go, because I printed out, so it says right after these are the instructions on how to do the SPS.
Is Chris still with us?
Chris?
I don't see her there. Okay, I'm going to invite her back in. I don't know what happened. I was thinking it was awfully quiet.
Oh, it says in the box. You can find the variances for each group by looking at the same output that generated the QQ plot. Look for the script. Oh, we haven't done the QQ plot. You haven't done your QQ plot yet, right?
I did do my. I did.
Oh, okay.
So let me go
sorry.
there.
Then I'm behind you. No, sorry. Okay.
Yeah.
Okay. We'll make a cube within analyze. Descriptive statistics explore, and then move the variable that contains, so that's my shoes, right?
Yeah.
And then is kicking accuracy, correct?
No, the kicking accuracy would be the descriptive because that's what we're trying to find. So it would be descriptive, and then the footwear, the recoded, would be the one that
factor.
Comes in. Yeah.
Okay. Plots, mark normality plots.
Yeah.
Click on continue. Hit OK, and then it says a bunch of output will be created. Look for graphs labeled normal QQ plot of. There will be one of these for each group. Do not use the detrended normal QQ. Okay, so so under descriptives, now it gives us the variance. So I have a variance for A 27.358.
Yep.
And then for B, I have 29.484.
Correct.
C 27.208.
Yep.
And D 53.158.
Yep.
And then E is 31.011.
Uh-huh.
And then SOX is 40.724.
Correct.
Okay. I'm caught up, so if you want to invite her back in.
Okay, I invited her. I don't know where she's at. I don't know what happened to Chris. But, okay. So the smallest variance for the groups, I think it was C at 27 point,
208.
yeah. Because the next one closest to that was A at 27.358. So,
Okay, so
and then
that's what it's asking is what's the minimalist?
yeah,
So that's 27.208.
yeah. And then the largest, so question 9 asked for our largest, and that's D, which is 53.158.
Wait a minute. E, you said, or D?
D.
Oh, D.
D.
53.1 what?
158.
158. Okay. And I didn't save that. Okay. So number 10 says the test for equal variances is satisfied for these data. So
Yeah.
is 53 3 times. Wait a minute. It's kind of weird wording again, right?
Yeah, but basically you just take 27.208 times it by 4, which gives us 108.832. So is 53.18 smaller than 108.832, which is yes.
Okay, so where are you at now?
Hi, Chris. Are you back?
I'm back.
Okay, we just are on question 10. So let's go back to where did we lose you?
On question 5.
5. Okay. I know, I thought it got quiet there for a second, and I was like, wait, where did Chris go? Anyway, okay, well, question 5.
I get this thing that says there's a call error, and then everything dies.
Oh, that stinks.
That's what I got.
So do you just have to wait for me to invite you back in? Is that what has to happen? Because I did go do that.
I just move out to the car where I can get that on the G thing. I think it's probably our internet.
Oh, gotcha. All right. So question 5, we said, it says to check if each group is normally distributed, do the following, and we answered the construct a QQ plot for each group.
Okay.
And then question 6, it said we assume the variance in each group is the same if the following happens. And we selected B, that the largest variance needs to be less than 4 times the smallest variance.
Okay.
And then question 7, we pulled, it said, in an ANOVA hypothesis test, it's equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? And we figured out that there were 6.
Yeah, there has to be a 1, 2, 1, 3, 1, 4.
And
that's
a 1,
3, and a 2, 3.
Yeah.
2, 4. That's 5, and a 3, 4. That's 6.
Yep. Okay. So then on question 8, it asked us to go use that soccer shoes data file,
right?
And then pull up the minimum. Well, we pulled up all the descriptive statistics, and I wanted to ask us what the minimum variance for the 6 groups were, and we got 27.208. Group C was 27.208 is question 8. And then question 9, it asks what's the maximum, and we put down 53.158.
Okay, so we're caught up to 8 and 9.
Yep.
Yep, we're now on 10.
Okay, so I 4 times the 27.208, and we get 108. So that 53 is less or equal to 4 times the smallest, correct?
Yeah, for question 10. Yeah.
Okay, so the test for for equal variances is satisfied. So is this one of those? It's a double negative, so it is satisfied, or we don't want it to be satisfied?
Yeah, it is true that the test for equal variance is satisfied for this data.
Okay.
Yeah. I know. Sometimes the wording, you're like, what do you really want? It says construct a QQ plot for each of these 6 samples. Each of the samples are approximately normal based on what you can see. I think they are, but I haven't looked closely.
Well, we
Hey,
already
guys.
did the cute.
Hey,
Hello.
Eduardo.
Hey, sorry I'm late. I was in another group meeting.
No problem.
Just kidding.
Nah. How are you guys?
We're good. How are you doing?
I'm doing good, man.
Good.
What do you guys?
So we're on the quiz. We're on question 11.
Oh, wow. Okay, hold on. 11?
We're actually like kind of. It's been. I don't want to jinx us, but it's been kind of flowing easy.
Yeah, it's not been too bad.
Okay,
So I'm looking at. Go ahead.
Wait, what? Oh, so you're in number 11?
Yeah, we're on number 11, and they're asking us to construct some QQ plots, which we did, and I'm looking at them, and they all look fairly normal.
Well, there'll be some of those that'll be off a little bit, but you just ignore those.
Yeah, if most of them are normal, then you just answer it. So number 11 would be true, that each of the samples are approximately normal.
Okay.
Okay, number 12, perform an ANOVA test in SPSS and observe that the p-value is 0.081. So you do that, then remove the SOX data and perform the test again. What is the p-value? They want us to remove the SOX data and perform the test again. So, I'll see if we can figure that out. Okay. Let me go down and look.
Well, the only way to remove the SOX is to take it off of the random values that you've got.
Yeah. Okay, let me see. So if we go up, analyze.
Could we do the one where we did the difference and minus the SOX from the other one?
Oh, but we would have to have two lines of data.
Huh. Okay, I'm thinking. So, contrast. See, I didn't run into any of this option in the. Trying to look at all those options. Options. Can we exclude cases analysis by analysis? Exclude cases listwise? Huh. I wonder if we can do that. Exclude. Huh. I don't know what I'm doing.
Well, if you exclude group 5.
Yeah, it doesn't give me an option. So if I go into the one-way ANOVA and I go to options, at the bottom it says missing values, and then it says exclude cases analysis by analysis or exclude cases listwise. So if I click on that and hit continue, it doesn't give me a, let's get rid of list 6. So I don't know.
Okay, can we get score by?
What was that?
Can we get the p-score by doing where's in my notes?
They didn't say anything about eliminating data.
No, that's really frustrating because
we can get the score by dividing. There's something in there about dividing the old upper one from the lower one.
I'm thinking. Let me go in and see variable view, scale input, footwear string, columns 8.
Well, the only thing I could think of is if we did independent t-tests between the groups that we want to, but that would be horribly long.
That's for an hour and a half.
Let's see. Data. Define variable properties. Sort cases. Sort variables. Copy data properties.
One of those things that you're supposed to know, but nobody kept.
Right, but we've never covered it.
There was one in the homework test that was like that too, where you had to do a paired one that we'd never covered.
Oh, wait a minute.
Yes.
What's the data called again?
Which data? Which one that we?
The one we're working on right now.
What's its file or what?
Mm-hmm. Yeah, in the data file.
Soccer something.
Is it soccer shoes?
Yes.
Oh, I was just wondering because there was one that had like two. I wonder if like one of them's already. Oh, that was the gratitude. It had a gratitude and then it had a stacked, and then wanted you to open the stacked. Never mind.
Okay, so I wonder if we just physically go in and remove the data, like we go in and delete it.
Delete it?
Yeah.
Oh. Yeah, you try that.
Okay, I'll try it. Oh no, I will. I'm going to do it.
The problem is we have nothing to compare it like if we're on the right track. You know what I mean?
Well, no, but it's like one of us can turn it in. Sorry, I got to get my thing to work right. Okay.
Will it allow you to delete the data?
I'm going to try. Let me get there. I'm almost there.
Delete all the fives.
Okay. Okay. I think I just deleted it. Yep, it's gone. Okay, so now let me run it.
Well, isn't socks the sixes? So you would just delete the sixes? But you would have to go all the way across, right?
Yeah.
From like line 101 to 120.
Yeah. Okay, let me go in.
And then you have to reanalyze everything.
Yeah, I'm going to go automatic recode just to make sure I've got it all. Okay. Okay. 2. This one, I'm going to put that back in. Okay. Ah, stop it. Okay. Let's see what happens. This is so much fun. All right. Analyze. Compare. One-way ANOVA. I'm going to put that one back in. Let me just double check something. Okay, it did do that. So let me just make sure I got everything clicked the way it's supposed to. Options. Okay, it did. Okay. So the new p-value that it gives me for the 5, yeah, is 0.309.
Okay, what's the answer for 12? Sorry.
0.3. Yeah.
You guys both talked at the same time.
0.309.
Thank you.
So Stacy, did you go through and delete all the sixes? Just delete them all?
Yeah, I did, and then I went and did another automatic recode just to make sure it only had the 5.
Okay.
Yeah. Okay.
So so for question 13, so are we using the new data or are we using the old data for a test statistic for ANOVA hypothesis test?
It doesn't matter. Yeah.
Oh, it's right skewed, right?
Yeah. Correct.
I'm getting all hot and bothered. It's not even an issue. I'm getting ready to fight them on their stupid answer.
I'm excited that same
Funny.
thing.
Yeah. Okay, researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, the sodium level. The data is available, blah. Okay, let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs. Okay, so we're going to go and...
Oh, because we
I need
now
to
have
look at the
3
data.
categories.
Right.
Yes. So we need to go and it has just the name, so we have to go do an automatic recode.
Automatic recode. Okay.
Type.
For type.
Yeah.
And we're going to name these hot dogs.
Nice. Okay.
And then we'll do it
All
alphabetically.
right.
So chicken will come up first, I think.
Yeah. Beef comes up 1 because they put it down as
beef.
poultry. Yeah.
Right.
So beef is 1, then meat, then poultry.
Okay, so then we're going to go to analyze and compare means. Because we can do 3, right?
Well, you go. Well, they want to know. Yeah. Let's see. What did they want to know?
Stacey, you're going to be so tired of us by the end of this semester.
No, I'm good. No, so they want us to create the QQ plot. So you go into analyze. No, excuse me. Yeah, analyze, descriptive, and statistics, and then explore. And then you're going to put in the dependent list. You're going to put calories because that's what they want to
first
know about. Yeah. And then in the factor list, your new coded stuff. And then make sure you go over to plots and
hit normality. Sorry.
Normality, yeah.
Yes.
Oh my goodness.
It's good. Hey, I understand you. We're good. We got it.
We speak the same language.
We do. We do. Okay. Here it comes. Finish. Okay. Okay, so I'm looking at those. They look fairly distributed for the most part. Wait, I only have beef, meat. Oh, there's poultry. I was like, where'd it go? Okay, so now what do you want to know? Question. Let's examine the calories first. Construct the QQ plots of the calories for each types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. So from the QQ plots, it looks... do you guys agree? Does it look fairly normally distributed? I thought it did.
Well, it says it's supposed to have like a little bit of curve. I mean, they seem to be all hugging the line.
Yeah.
That the poultry one is a little bit off, but I don't know exactly.
Not to make a difference.
I don't know what they judge it on.
I think the majority have to be on. If there's a little bit of a variation, then they don't.
So those are your outliers. If you were to do a histogram, you'll see those out there in the floaties somewhere.
Yeah, but most of the data is there. So I would say yes, that they're normally distributed. And then looking at the variances, if you go under this descriptive box, you've got 512.661 for beef, 636.846 for meat, and poultry is 508.566. So definitely.
So is meat like all the above or anything?
Yeah, it's a mix. It's a mix of the beef, poultry, and.
Oh, I bet they're gonna have us take that out, huh?
That's right. But if you look at the numbers, the variances are definitely considered equal because
yes,
the high, yeah,
bigger.
Yeah. Okay, so I think the answer would be A, the assumptions have been met. It's safe to assume each group comes from a normally distributed population, and we can also assume that the variances are equal. Yeah, I think it's A. Looking at the others. Okay, it says run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, and that the p-value is 16.0. No, the F statistic is 16.074, and that the p-value is 0.000 with a level significance 0.05. So,
when we go to analyze and then compare means to the end, so our calories are the dependent list. Or is it
Yeah.
or am I backwards again?
No, calories is your
calories
dependent
dependent.
list.
And then our factor is the whole hot dog list, right?
Yeah, yeah.
And then we have to go to
make sure
options
you-
and hit descriptive and means plot, right?
Yep. Yeah. Okay. Yeah, I got this. I
Okay.
got the right numbers that they got, so looks like we did it right.
Did any of you guys get that? I got a what was it? I got an email today to do. It's from like an independent company about my education, and it asked you like how often as a teacher like described, and I'm like, you have no clue that online is. And I'm thinking like just now, I'm like, we're teaching each other.
That's right.
Right.
And like I have never talked to our teacher.
Yeah.
You know what? There's no online tutoring either.
No.
But anyway, sorry. I thought I'd share that with you.
No.
Okay, so the degrees of freedom are 2, 51, and 16. Oh,
Okay.
well, I got a 50. Wait, oh, F equals 16 point, and then P equals 0, 0. Okay.
Yeah.
What conclusion
So
can you draw?
Okay, so what?
Well,
Where were those? Question 14 was what?
Oh,
question.
What was
Which
the
one
other
do you?
question?
Which question do you need?
14.
14. 1 4.
Yeah.
We decided it was A, that the assumptions have all been met.
I thought that was
Because no, 13 asks the test statistic for ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or to the left of the F statistic?
Oh.
And we said it was the right.
Okay.
So 14 will be choice A. And then 15, it says, it gives us all, we made an ANOVA test and compared and we got the right. So it says, what conclusion can you draw? So you look at the p-value, which is 0.000. It is less than than our level of significance. So
you
go ahead.
reject it.
Yeah, we reject the null hypothesis, meaning that C, we have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories. Well, no, actually, cancel that. It's D. We have sufficient evidence to claim that at least one of the hot dog types has a different mean. I didn't even read that one. I'm glad we stumbled on that. Okay.
Oh, so now we have to go back for 16 and run it all sodium?
Yeah. Construct the QQ plots for sodium level. You should see that poster plot.
Okay, so we're going to descriptive and then explore.
Okay.
And then, so instead of calories, we're going to put sodium in that.
Right.
Yeah.
And then we have to.
You keep the type, the factor list the same.
I was gonna say, but when we go to plots, it kept caped. Sorry.
Yeah, you're fine.
It kept the normality plots.
Yeah, it did. It's the same. I mean, then you can go do an ANOVA test if you want to do it already. I don't know if they'll request it of us, but
we can be proactive.
That's right. Okay. So.
Oh my goodness, this is like insane. Like, I seriously would not have figured this out without you guys.
That's why it's good. Oh, okay. So look at the QQ plots for sodium.
Yeah, what was 16 then? Sorry, was it D? No.
Sorry, which question again?
16, sorry.
You said 15?
16.
16? We're still working on it.
Oh, okay.
Let's see. You should see that the QQ plot is a possible problem with the normal. So I'm looking at the QQ plots, and I don't know.
I suspect that it's going to not be normal.
Yeah, they're a little bit crazier.
Well, like that second one, the meat one, they're all kind of bunched toward the top.
Yeah. which is okay
And
as
then
long as they follow that line fairly well. The poultry one is the one that's a little crazy. Okay, so it says let's examine the sodium levels. The QQ plots of the sodium level for each of the 3 types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 71, 80, 75, and the largest is
10,400.
10,000. Yeah.
10,000, yeah.
So then they want to know
4 times the smallest.
4 times 71
Yeah.
is going to be about 290.
So it does fall
well,
under that smaller than or equal to.
Yeah, the variance is okay, but because that poultry is not, it says it's asking us if the assumptions are correct.
I would say no.
Yeah.
Yeah, it would be, I think it would be C because it says the assumptions have not been met. It's not safe to assume that each group comes from a normally distributed population, but we can assume that the variances are equal.
I agree.
Okay.
Yeah, that was all like gibberish to me. I'm like, huh?
Well,
Okay.
Well,
I'm always a little.
Oh, look. See, you're onto something, Stacy. It says, because question 17 says, despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is your p-value? See, you were onto something.
Gotcha. Well, they kind of said it at the beginning, and I was like, "Okay, but is this a trick question? Do we ignore it like we did all the other ones? Like, well, it's not really normally distributed, but we're going to act like it is."
Yeah.
And I was like,
Because you're special.
"Okay, okay." So I.
Oh, go ahead. So what's the
No,
p-value?
you're good.
The p-value, isn't that the sig?
Yeah.
Yes.
And it's 0, 0, 0. Right?
Well, if you do the, no, it
Or
was.
am I looking at the wrong one?
You're looking at the wrong one. Did you do a new one for the sodium?
0.179. See, I shouldn't have done the ANOVA first because then it removed my red.
Oh, the red one. Yeah, yeah.
Okay, so I have 0.179.
Yeah, that's what I got as well.
Which is higher than our alpha, isn't it? Do we have an alpha?
Yeah, I'm sure it's.
Oh, next question. See, we are on top of this stuff.
That's right.
So question 17 is 0.179.
Yep.
Whoa, what was it? 0.79?
0.179.
0.1.
What conclusion can you draw with the mean sodium levels of all 3 types of hot dogs using an alpha, a significance of 0.05? Well,
so,
it's higher.
Yeah.
So we don't.
Yeah,
it's double negative.
Right. We failed to reject the null hypothesis. So it would have to be either, so we don't have sufficient evidence, but that's not, we actually want to have it, let's see, we have sufficient evidence to claim that all 3 hot dog types have the same mean sodium levels. That's an option, because the next one, if we're
not.
Yeah. Number C is wrong.
That's usually what I end up doing, is eliminating the others and then come back to the 2.
Yeah, I think it's A, because if we fail to reject the alternative, or excuse me, if we fail to reject the null hypothesis, that means
which originally our null hypothesis is that they're all equal. They're all means are equal.
Yeah. All right, you guys, I'm going to submit it.
Oh, would you guys put for that one?
A.
A, okay.
Okay. All right, let's see what damage is done. It's looking good so far. Oh, that last one they didn't like. Stupid thing.
Do you mind like giving me like the answer for 3 to 10? Or...
Yeah, we can. Let's see.
I wonder if that's a typo because it passes the.
What's on the last one?
Because so the variance, the rule for the variance is if
No, it's about the p-value. So either we got the p-value wrong, which is what I got when we ran that test,
And if
or we just didn't.
wrong, 17 would be wrong too.
that's true.
That's true. Never mind. So they're just confusing us with their words. Okay.
So
let's see.
Once again, our
You know
p-value is higher than our
Yeah.
alpha.
So there's two options on there, right? That where we have a p greater than the significance.
Okay. So we have greater, so we failed to reject, but this is what's crazy. So we have sufficient evidence to claim that all 3 hot dog types have the same mean sodium level. We do not have sufficient evidence to reject the claim that all 3. Okay, that's the one it is. It's worded weird, but it says we don't have sufficient evidence to reject the claim that all 3 types have the same sodium. So that's it's B. Yeah, it's B. Dumb.
Once again, double negative.
I know.
Yes, it's 100.
Yay.
Okay, so what was number 3 to 10?
Yeah, I'll go over that with you. Chris and Carrie, if you guys are done, then